Am I on? I'm on. Great. Good morning, everybody. I know it's early. I'm like you. I'm not a morning person. I'm a firm believer there should not be 2 9 o'clocks in a day. We haven't even made it to 9 o'clock yet. So let's do this real quick. One more little warm-up, one more little exercise. Everybody stand up, please. This is a quick one. We're just trying to get some random distribution in the audience. So think of the day you were born. I was born on July 10th. 10 is an even number. If you were born on an even day of the month, hold your hands out in front of you like this. And if you were born on an odd day of the month, put your hands together like this. Hold that, hang on. See if we can do this. Flip it around. Now I can tell everybody I got the first standing ovation from an opening keynote at GIDS. Thank you. You can sit down. But thank you so much. And like I said, my name is Michael Carducci, and it's an odd background to have to be a software engineer turned magician. I always moonlight as a magician. And it was interesting. I learned a lot of valuable lessons. But I'm going to talk today about a few of the different lessons I've learned that were valuable and maybe a lot more painful. And to answer your question, I am still an active practitioner. The cruel irony of life is even though I quit my day job several years ago to do magic full-time, I spend more time writing code now than I ever did as a corporate coder, and that's just kind of how things go. But you know, throughout my career, whether I was pursuing mastery as a magician or pursuing this as a software engineer, I always wanted to be great. I always wanted to not just be good, to be great, to be a great software engineer. And that's a difficult thing. That's something I always chased. That's something I always pursued. And in the process of that, I think I ran aground just a couple of times. But when I look back over my career, over 2 decades, and I think of all the different people I worked with, maybe a handful, maybe 3 people in 2 years, or 20 years, I would consider to be truly great. Now, I've worked with a lot of smart people. I've worked with a lot of fun people. But when I look back over the entirety of my career, in 20 years, 3 developers I would consider to be truly great. And I want to open this up just as a question really quickly. How many people have been practicing software engineers for longer than me, more than 20 years? Just kind of a show of hands. We got a couple front and center, right up here. How many years, if you don't mind me asking? 24 years. And when you think about those 24 years, how many developers would you consider to be truly great? For me, it was 3. Quite a lot? Okay. Wonderful. Wow. Well, and there's a lot of great developers here. And that's a really wonderful thing as well. So that's tremendous. That's a tremendous opportunity. And what I found, though, is more often than not, a lot of people, they find they've worked with about one truly great developer per decade. I see people 2 years, 20 years, 30 years, 3, 4 is usually on the high side of great software engineers that they've worked with. And I thought, okay, I wonder if we could distill that down. I wonder if we could wrap that up into a 45-minute morning keynote. We could all show up. I could talk about what it takes to be truly great, and we can leave, be great, and have great careers. And that led to this question right here. What does every programmer need to know to be great? Thought about that, and that led to a more difficult question. How do we define a great programmer? Well, that's easy. We're all great, right? We've all occupied this little tiny sliver of the bell curve. We're all great programmers, right? At least every now and again we feel that way. We tend to, at least. I know every single time I've stopped and looked at something I did, kind of slide my chair back, look at the screen, and I'm getting the hang of this. I'm a really great developer. Every single time I thought that, within minutes, sometimes hours, I was immediately reminded, no, you screwed up and you messed up badly. There's a simple question I ask people sometimes to kind of gauge where they're at. I asked a question, how many people here have to work with bad code? Now, you don't have to raise your hand because it's literally all of you. But I would ask this question just to kind of get a sense because it's kind of interesting to see where we are. We look at this. But yeah, we literally all have to work with bad code all the time. In fact, I used to have people raise their hand, and only once did somebody not raise their hand. One time. Everybody in the room raised their hand except for one person, and I had to ask. I said, now, you didn't raise your hand. I have to know, did you write all the code? or are the people who wrote all the code in this room? Because that's the follow-up question always. How many people here wrote the bad code? I know I wrote most of the bad code. I've been the person who wrote all the code, and I still start looking at something that I haven't touched in 6 months or 9 months or a year, and I'm looking and I'm thinking, who on earth wrote this? What were they thinking? And oh, yeah, that was me. And I don't know what I was thinking. But I do kind of know what I was thinking. I was trying to be great. I was trying to be considered by a lot of people to be great. This is what I wanted. And in this pursuit of greatness, I ran into a lot of what I would call problem-solving anti-patterns. Now, anybody who's been in this industry long enough, we know anti-patterns are bad things. We know that they're bad things, but I think it's worth mentioning that anti-patterns are distinct from bad things. And we know that if nothing else because we already have a word for bad things, and that's bad things. But they're distinct from bad things because they seem like they're good things. And I'm paraphrasing Neil Ford, who I know is speaking this week. And he actually wrote a great talk called Why Yesterday's Best Practice Becomes Tomorrow's Anti-Pattern. And I like how he described anti-patterns. He described them like this. He said, anti-patterns are something that looks like a pleasant walk through the park on a nice path lined with flowers. And then you start walking down that path, and you find out that actually it's a maze filled with monsters. And now you're lost, and you can't get back out. The problem-solving anti-patterns that I kind of independently ran into, there were a number of these. Writing from scratch what already exists, sweating the small stuff, putting my wants ahead of the needs of my team, my organization, over-engineering, that was one of my favorites. Rewriting perfectly functional code because it doesn't look pretty enough. The ground-up rewrite, I was guilty of that a couple times. Resume-driven development, that was another signature move of mine. And of course, the golden hammer. All of these came from a good place. I was trying to do good things. I was trying to do great things. But the result was anything but. And it started with a simple notion that went all the way back to my childhood. The notion was this. A great programmer is somebody who knows more than I do. That makes sense, because I'm pretty good, right? And I've always been pretty good. 7 years old, writing BASIC on an Apple II, I was pretty good. But anybody who knew more than me, well, if I'm pretty good, they must be great. This was my first programming book, 30-ish, almost 30 years ago. It was a book on BASIC for the Apple II. Now this, I read, in fact, I devoured this innocuous little folio, all 67 pages, all the way up to the advanced topics in the back on subjects like if statements and for loops. By the time I finished that book, I thought I had pretty good mastery of the basic language. And then I met my neighbor who had a lot of experience in IT, and he had a lot of experience as a developer, and he saw in me just a little bit of him, and he wanted to encourage, he wanted to nurture that spark, that passion in technology, and he gave me a copy of Byte magazine. And in the 1980s, Byte magazine was kind of an industry publication, and there were articles, there were advertisements, there were reviews, and in the back of every issue of Byte magazine, there was a BASIC program. Now, I want to put this in a little bit of context for you. The first BASIC program I ever wrote looked something like this. Right? Makes sense. There we go. And then I started reading through the pages of Byte magazine, every single article, every single advertisement, and then I got to the back, to the BASIC program that was included in the magazine that we could type up and run on our machine. We could build with ourselves with our own two hands. And I thought, BASIC. I know BASIC. I'm pretty good at BASIC. I know exactly what on earth is that. If peak 768 doesn't equal 169, what? Poke 784, comma T, poke 789, comma S, poke 779, comma D, poke 774, comma SL, times 16. And it goes on like that. That is one line of code. Like I was looking at it, I thought I understood BASIC, and whatever that is, I did not understood. I couldn't even say understood. I did not understand. But I thought whoever wrote that must be a genius, right? They must have risen to the highest echelons of our industry, which I was sure at the time was writing BASIC programs for a magazine. But because I couldn't understand it, I was enamored by whoever wrote that program. And that line of thinking directly led to me writing this. This is arguably one of the worst things I have ever written in my life. And I know this for a number of reasons, but one of them is nobody has ever been able to tell me what it does. I worked for a company, by the way, this is a SQL function, and this is probably a little difficult to read in this room. This is by design. 12, 13 years ago I wrote this. Nobody's ever been able to tell me what it does. If you told me what it does right now, I would be a little angry. You would have broken my winning streak. So, yeah, it's a little hard to read. It's okay. But I will tell you a little bit about this. I worked for a company as a SQL developer. And it's kind of good to bring this up on the day-to-day. If there was anybody who was going to catch me out on this and tell me what the code does, it would be today on cloud and data. So I'm being a little careful. But I worked for a company. We dealt with a lot of very big, very challenging data problems. We were dealing with kind of quote-unquote web-scale problems before we even had a word for this. And I worked with about 40 or 50 really talented, really smart SQL developers. And in that time, we would send things around for a code review. So I wrote this. I was so proud of it. I emailed it around for a code review. I didn't care about people's feedback. I just wanted people to tell me how great it was. So I email it around, and I get a couple replies back, including one from a man named Rick. And Rick was one of the most senior people on the team. He was one of the most experienced people on the team. Very, very smart person. And he wrote me back, and I quote, "This is beautiful. What does it do?" And that was just too much. I'm just like, yes, I'm even smarter than Rick. And I wrote back what it did. And it's a very complex, a very optimized piece of SQL that I wrote back and described in detail what it did. And what he wrote back, I'll never forget, he said this: "I am not smart enough to have come up with what you've come up with here." And I say that in all earnestness. I know that's what he said because I actually printed that email off. I still have it. It's laminated. But this function right here is bad enough that nobody can even comprehend what it does. If I told you what it does, I promise you would all judge me. This function is an unreadable, highly optimized, over-engineered function to do a URL encode on a string. My idea was that if you needed to do a URL encode, you should make a database call. This was my idea. And I was so proud of this that not only did we put this in production, we started using this all over the place, I uploaded it to the internet. I uploaded it to the internet to a repository of scripts so other people could pull that down and use that as well. And they have. It's been downloaded thousands of times. They've rated it 5 stars over and over and over again. And I feel like I have to give this talk, if nothing else, for penance about all the things that I've put out into the world, including a whole universe of people where they're making database calls to do a URL encode. That was ridiculous. One of the worst things I ever did. But I loved the fact that nobody could understand it. Because if a great programmer is somebody who knows more than I do, then I must be a great programmer if I know more than my peers. But the truth is, it doesn't matter how clever my code is if my team can't maintain it. And I'm going to tell you a little secret. I can't even maintain that code. If I had to change something, I would basically have to write it from scratch and then over-optimize it again. There were several problem-solving anti-patterns in that little exercise. I was writing from scratch what already existed. There's nobody in this century who will ever have to write a URL encode function. The only possibility is maybe there's some kind of extinction-level event, and there's like 3 developers left in the entire world, and all the libraries are gone, and we decide that we're going to reinvent the internet exactly the way it was. And we need our URL encode function. I over-engineered. That function would scale linearly. Like you could throw a 2 gigabyte string at that, but at that time, that version of SQL Server had a cap of 4,000 Unicode characters. So we didn't really need all that performance. It was never going to be that long of a string. By the way, even though there was a cap of 4,000 characters, has anybody here ever URL encoded a string that was 4,000 characters long? No, literally nobody in this room, and there's probably 1,500 people in this room. Over-engineering. The golden hammer. I was a SQL developer, so everything that I built was written in SQL. And I loved it. It was a good challenge because SQL is a fairly simplistic language. So I always found myself asking the question, could I write this in SQL? The answer, it turns out, is probably yes, and the answer is also don't do it. Took me a long time to learn that lesson. But I'm not alone, and this is why I don't feel bad talking about this. Again, to quote Neil Ford, I quote him quite frequently. Developers are drawn to complexity like moths to a flame, frequently with the same result. And I went through a lot of different notions over the 20 years of my career trying to figure out what it really takes to be a great programmer. And I finally figured it out. There's no metrics. There's no guidelines. There's no way to measure it, even if we're looking at like objective measurements of code quality, cyclometric complexity, any of these things. No, it's as simple as this. Good programmers write good code. Bad programmers write bad code. I think we can agree with this, right? Okay, I like that you're reserving judgment on this. Because we're only 15 minutes into the keynote, we haven't gotten to the real lesson yet. Good programmers write good code, bad programmers write bad code. But 20 years ago, I got a job working as a Visual Basic 6 developer. Has anybody in this room ever suffered the indignity of writing Visual Basic 6 code? Okay, we've got some hands going up. Not a lot of people, that's good. And even fewer would admit to it, by the way, usually. So I applaud your courage. I feel okay talking about this because we've all done things we're not proud of when we're younger to pay the bills. This was one of mine. I was a Visual Basic 6 developer. It's an awful language. It really is. You would agree? You raise your hand. You're here, actually, yours was the first one that went up. So you've been there. You've done that. You've got the T-shirt. I worked as a Visual Basic 6 developer at a company, and I'll never forget my first day on the job. They gave me a laptop. That was awesome. In the 90s, getting a laptop, that was a big deal. And they said, familiarize yourself with the code. So I start looking through the code, scrolling through it, and I found immediately it was bad code. In fact, I have a little excerpt here, right here on the slide. Again, it's a little scaled down, but that's okay. I'm going to point out some of the obvious problems with this code. And I don't know if you can see that or not, but I'll highlight these. First of all, Hungarian notation. Since the development of the IDE, I felt like Hungarian notation was something that should die. In my opinion right now, Hungarian notation is one of the 3 worst things that ever came out of Microsoft. And then we're modifying a by ref parameter. So for those of you who didn't have the joy of spending a lot of time with Visual Basic, in the parlance of Visual Basic, when you pass a string to a function, it gets passed, in their parlance, by ref. In other words, you're passing a reference to the string, which means in this particular code here, when you're modifying that variable, you're modifying the calling function as well. So your code is now bleeding across boundaries. That's like a rookie Visual Basic mistake. You don't do that. You do one of a few things. You either pass it explicitly by val, you either reassign it to a local variable inside the function, or you just don't do that. And then look at this, select star from, come on, what are we, animals? And white space, right? This was objectively bad code. So they said familiarize yourself with it. Meanwhile, I'm scrolling through the code base, shaking my head, clicking my tongue, patting myself on the back, saying, thank goodness, these old timers have some young blood in the company. I'm going to show them the light. So I didn't just familiarize myself with the code. I fixed it. I turned all of this bad code into good code. Now again, this is a huge room. I don't know if you can read that or not, but it really doesn't matter. You're way in the back. Even if you can't read that at all, doesn't that look like good code? That looks like a beautiful code. And I fixed everything. Thank you, one person clapping. I fixed everything. Got rid of the Hungarian notation, camel casing for the variable names, Pascal casing for the function names. I'm not modifying a by ref parameter anymore because I read the documentation on ADODB, and I know I could give it a command type of AD command table and then just give it the table name. That's all I have to do. And then it creates a select star from. I don't have to have a literal select stars from and concatenate SQL like a crazy person. And all of it, beautiful, organized. It was great code. It was beautiful code. I was so proud of myself. I bought myself a beer that night. Of course, before I checked it in, I tested it. Okay, let me rephrase that. Of course, before I checked it in, I compiled it. It compiled, and we shipped it in an era where shipping it literally meant shipping it. Doing a release took months because we literally had to go from client site to client site with a floppy disk and a visitor badge. Put the disk in, run a batch file, wait. Next computer, put the disk in, run a batch file, wait. And we would go from client site to client site and client site. We would do deployments all summer. We did annual deployments. We wrote software for schools. And I'll never forget the first day of school. They said, come in early. I made it in. I'm going to consider that a win. And I came in. And besides, they wanted us in at 7 o'clock. The schools don't start at 7 a.m. Why should I be there at 7 a.m.? I got there more or less on time. And I sat down at my desk. And as soon as I sat down that day, I'm never going to forget this, my phone rang. The phone on my desk started to ring. Can you believe the indignity of this? As a software engineer, I had to answer the phones. Whatever, it's a small company. I'm a team player, so I answered the phone. And I heard a voice on the other end say, yeah, hi. We're getting an error 800E2571. And they always stop there, by the way. They always stop there after they read the error number like that means something to us. We're technical. We get it. Kind of like how we're supposed to know what it means when they say, my printer doesn't work. Of course we know. We're just not going to tell them. 800E2571. I'm sitting there. I'm like, keep reading. And the index out of range exception? Okay. And I create a bug ticket. I'm polite. I'm trying to make them feel better. I'm like, I'm so sorry. We'll give you an update as soon as we have one. No, I understand how critical it is. It's the first day of school, and I understand. We'll give you an update as soon as we have an update. All right, thank you. And I go to hang up the phone. And when I hang up the phone, I see something I have never seen before in my life. Every single light on that phone was lit up. Turns out we had 20 lines. I had no idea. So I answered the next call. Thank you for calling. I had a little script taped to my desk, if you can believe that. Thank you for calling. How may I help you? And the same thing. Hear a voice on the other end of the phone saying, yeah, hi. We're getting an error 800E2571. And I'm on the phone here thinking, what a coincidence. I go and update the bug ticket. And I answer the third one. And it's the same thing. Yeah, hi. Error 800E2571. I didn't answer the fourth line. I didn't go back to my desk. I spent the rest of the day in the bathroom. I was hiding. Turns out, when I made that modification, I missed something. You see, that whole code bleeding across boundaries thing, where the calling function now had select star from added to the variable, they were stripping it back out. They knew about that. They noticed that. And in that function, if you call the instra method, which is looking for a string inside of another string, it returns -1 when it doesn't find the string. Now, if you're taking the output of instra and putting that into mid, which is the Visual Basic substring function, -1 is not a valid starting position. And that's going to throw an exception. Now, if you look at that code, you'll see a complete lack of error handling, not even the glorious on error resume next, which was actually a thing. You remember, in Visual Basic, you could tell the compiler, it's Visual Basic, how bad could it be? If it throws an exception, just keep going. And people would do this. And in some circles, it was considered a best practice, just to ignore every single exception ever. I didn't go into work the next day. That was a pretty frightening and humiliating thing. I finally came in the third day, walked into the office, and as though he was waiting for me, my boss saw me walk in the door, and he sees me, he greets me. He says, Michael, good to see you. Glad you're feeling better. Conference room in 5? And I'm just, so they know, okay. And I go back to my desk. I've got 5 minutes to kill. And I start organizing all my things together. I try to get everything, all my little things that I brought to work, photographs and tchotchkes and my own personal mouse pad that had Homer Simpson on. I grabbed everything together into one pile. So as I was taking the walk of shame out of the company, never to return, I could just take a file box, scoop everything up, and walk out the door. And I've got 3 more minutes to kill. I didn't have that much stuff at the office. And so I sit in the conference room, and I wait. After what seemed like an eternity, my boss walks in, and he sits down on the edge of the table, and he says to me in a way that I think only the British can pull off, because it was a mix of charm and contempt and anger and politeness, like all rolled together. And he looks down at me, he smiles, he says, Michael, what the hell were you thinking, mate? And I'm young, and I'm trying to explain, like, that was bad code. I think you'll agree. That was objectively bad code, and I made it better. And I'm trying to explain what I did and why I did it, and none of it came out. Not a single word that I intended to come out came out. All that I was able to say was this. I looked up, and I very meekly said, I fixed it. And he looks at me and says, now, Michael, I think what we have here is one of our Anglo-American linguistic disagreements. Let me give you an example. Years ago, we invented a game. You play it with a ball and your feet. We call it football. Now, you Yanks invented a game. You play with a ball and your hands, and you call that football. Here in England, the birthplace of the English language, to have fixed something requires a transformation from it being in a non-functional to a functional state. Now, I think you'll find in this instance that we actually transformed it from a functional state to a non-functional state. That would be the opposite direction. That, in my understanding of the language, would be the opposite of fixed. What would you call that? That's right, you broke it. And I didn't know what to say to this, so I'm like, no, I fixed it. Michael, we'll try this again. And we went through this again and again and again. And finally, this man of infinite patience lost his infinite patience. We got to the mic drop moment. He says, well, you know what, Michael? I like the way that my broke code works better than the way that your fixed code doesn't. And that was it. He walked out of the room. Somehow, I don't know how, but somehow, I did not get fired. So I decided to do what anybody would do in this situation. I doubled down on greatness. That's right. It wasn't just good code or bad code. I came up with a new definition of good code. The definition of good code is the best code is the fastest code. Now that makes sense. That's something you can measure. If I write something and you write something and they both do the same thing but mine is faster, mine must be better, right? I'm glad nobody said yes. Thank you for that. That's what I thought, the fastest code, because they gave me one of those go away kids, you bother me projects. One of those projects that they give you, they say, work on this one little thing, this one little tiny thing. They thought, if the scope of what we have Michael work on is small enough, he can't possibly screw it up this time. Oh, how little they knew me. One method in one module optimized this. They gave me 2 months to do it. So I didn't just optimize it. I became guilty of extreme optimization. Yeah. By the way, this isn't me. I want to point this out. I do skydive. I'm an avid skydiver. I'm a passionate skydiver. But this is not me, and it kind of kills me. I really want to get a picture like that. I think that'd be a cool picture. Now, the reason I haven't done that is a couple reasons. One, nobody will lend me their laptop to take a picture with. But also, like, I've tried to buy a laptop, and believe it or not, if you want to get an old, cheap laptop, let me throw a spec out there. A laptop from 1995, 386 processor, 33 megahertz, 4 megabytes of RAM, 20 megabyte hard drive. You're nodding. How much would you pay for that, sir? Dollars or rupees, I don't care. What would you pay for that? 33 megahertz, 4 megs of RAM. What would you pay for that? Maybe, yeah, maybe, and that's generous. Not even. In the U.S., $200 U.S. minimum. I have no idea who's buying these laptops, but that's what they're paying. I think it's hipsters. I don't know. So I'm not going to spend $200 on a laptop that I'm only going to use once. And yes, I can get a broken laptop, but who wants to take a picture with a broken laptop? That's crass. No, I don't want to just pose for a picture with a laptop in free fall, in midair. I want to write a program on the way down. Now, there are 2 reasons for this. One of these, very simply, bragging rights. That might be one of the coolest things that I ever do in my life. Yes, I have a very warped definition of what cool is. But bragging rights, I think that's a big one. And the second reason, and arguably the better reason, the jokes. Think about it. right? Imagine. When you're jumping out of an airplane at about 14,000 feet above ground level, I think that's like 4,000 meters, something like that, you've got about 45 seconds of useful free fall time. About 45 seconds to do whatever you're going to do before it's time to deploy your parachute. And it takes a few seconds to get stable. So imagine this. I've got my laptop. It's booted up. My IDE is open. And I'm in the door. The light turns from red to green. I look at the person who's got the camera, and I nod, and they nod. And then I count out 1, 2, 3, and I'm out the door, and now I'm getting stable. I'm getting stable. They're taking pictures, and I'm in there frantically writing my program. And before I know it, I hear the alarm in my ear of an audible altimeter to remind me, in case I'm not looking at my visual altimeter, that it's time to deploy the parachute. So I'm like, oh, time to go. So I wave my hands, I deploy the parachute, and the G-force of the deploying parachute causes me to drop the laptop, and I watch it disappear towards the earth, and I'm glad there's only a couple of houses down there. I'm like, oh no. Parachute is deployed, and I pilot it, and I land. And all my developer friends are on the ground, and they're dying to know, so, did it work? Did it run? And I can say, it crashed. Yeah. No, that does not deserve applause. Are you going to try again? Well, I better defragment my hard drive first. What program did you write? Hello, world. What was the best part about the experience? Cloud deployments were a breeze. You can keep going. The jokes write themselves. But I became guilty of extreme optimization. They gave me 2 months to optimize that one method. And this method involved a lot of string manipulation. Now, you raised your hand. You had a little bit of experience with Visual Basic 6, the old Visual Basic, not even the .NET, which is not the same as Visual Basic, by the way, in case you're wondering. Visual Basic 6. How would you describe the performance of string manipulation in Visual Basic 6? Did you say pathetic? Yes. And it's also very, very slow. The best answer I've ever gotten to that, by the way, I said, how would you describe the performance? They said, glacial. Moves about an inch every 1,000 years. Yeah. And so I decided the first thing I was going to do was I was going to optimize the Visual Basic. So I did what anybody would do, I think. I rolled my own string type. That sounds like a good idea, right? And I rolled my own string type, and I built my own string manipulation methods. So in my string type, I just stored it as an array of bytes in memory, and I had addresses of where that started and ended, and I would just move bytes of memory around to do the manipulation that I needed to do. And because I found some old low-level Windows 32 API methods, I could give it an address, and I could basically say, move this byte of memory from here to here, copy that byte of memory from there to there. And I tested it. It actually worked pretty well. It was reasonably fast. It performed a lot better. But I still had about a month and a half to work on this. That's a lot of time for me to get in trouble. And so I asked myself, is there any way that I could make this faster? Then I looked at the code. And ultimately my code, all I was doing was moving bytes of memory around. I looked at it and thought, I could do this in assembly language. Now, they say that you can't mix Visual Basic 6 and assembly language in the same project. Lazy people say that. It turns out the Visual Basic 6 compiler was the same as the Visual C++ compiler, which meant that it also accepted all of the same command line arguments. So I could compile my Visual Basic 6 by hand into assembly. I could write a module in assembly, and I could just look at the compiler decoration that the VB6 compiler gave me. I could swap the files out, compile it, link it, ship it. And it was really fast. I mean, it was insanely fast. But, of course, I had to do the build because it was a fairly convoluted build process. And I'm a team player, so I did the build that year. And then I did what anybody would do. I quit my job and left the country. I moved back to the United States. And I'll never forget the day my phone rang. It was my boss. I couldn't figure out who's calling me because it was a brand new number. It was an American number. I thought, who's calling me? And I answer the phone, and I hear a voice on the other end say, Michael! It's Tim, my old boss. I said, well, hey, Tim, what's up? And he said, that import routine you wrote, where is it? They couldn't find it. Because over the course of the time after I left, they decided to do a source control migration. And there's 2 ways to do it. They did it the other way. They just checked everything new into the new source control platform, and they decided to take the opportunity to clean up all the random compiler artifacts and garbage and debug symbols that people have been checking in. And my little assembly module got swept up in that net. And it was gone. I suggested that they pull it from backups. Turns out that employer, backups, were kind of like an idea, right? He said, well, all the developers have laptops. They all take them home at night. What are the odds that all 12 developers' houses are going to get robbed and the office burns down? Am I right? We don't need backups. And I had to write it again. And I used all the negotiation tricks I knew to negotiate him to a price of free and a schedule of now. And I rebuilt it. And I learned a lesson. You know, we could argue about good versus great, and maybe, a good developer knows how to make low-level optimizations like that, but a great developer knows when to leave them alone. And so if I'm completely honest, if I'm completely objective about my motives, I did this because I was tired of getting made fun of for being a VB6 developer. I thought writing code in assembly language would make me cooler. I wanted to show off. Ultimately, I put my wants ahead of the needs of my team, my organization, because Visual Basic 6 would have delivered significantly more value. I thought great programmers used real languages. But I'm going to share one more definition with you before we run out of time. I thought a great programmer, we don't need no stinking library. We don't need no framework. I can build everything by myself. And I've made this mistake several times. It turns out that I'm not as good as thinking through all of the edge cases of the people who built the commercially and freely and publicly available libraries. But I'm not going to tell you my story here. I feel like I've thrown myself under the bus enough. I'm going to pull a colleague in here to join me. One more story. Because I talk about this, and we've all kind of made this mistake at one point, or a lot of us have, that we start building our own everything. Rather than using what's already out there, we build it from scratch. We reinvent the wheel, or as Ken Cousin is fond of saying, more often than not, we reinvent the flat tire. And we do this. We build things that we don't need to build. I built my own URL encode, even though there was several options available to us. And some younger, naive developers will say, now, Michael, nobody would arbitrarily write code that already exists, would they? And to them, I say, yes, they would. I worked for a company, and we built an application that did a lot of stuff with search. We basically enabled our customers, our users, to search through vast quantities of documents, 50, 100, 150 million documents, to find needles in a haystack. Now, we did a lot of cool things with the technology. We did some machine learning. We did some analytics. We did some analysis of all these things. But at the core, it was a big search engine. We just built Google, but it wasn't as good. Google does stemming and synonyms and does all these things. Our search engine didn't do any of that. So you had to write very complex search queries. And they were very verbose. And the language that we used for the search queries was very verbose. But people would use it. They would build these complex search queries. And these search queries got to be several K in length in some instances. Now, we decided that to run one of those search queries against a universe of hundreds of millions of documents to find matches, that took a long time. So we decided to make our searches immutable. In other words, if you change your search definition, that becomes a new search definition. And if you change it back, it just updates references back to the old one. And that's what we decided to do. Now, obviously, we wanted people to test very quickly and very efficiently to see if a search already exists or not. Now, we could index the search column in the database, but that would be pretty inefficient. It's a very wide column. So we wanted a narrower column that we could index. So we decided to store a hash of the index of the search, and then we would index that hash of the searches. And that was a nice compact column, and that's what we did. And we deployed the project, and it went very well. People enjoyed it. People were using this. Except for one or two customers, they had some issues, right? Every now and again, I'd get a bug ticket going across my desk, and I'd look at it, and I'd give it a minute of my attention. Click. Click, click, cannot reproduce, closed. I think I'm going to call it a day. And then I go home. A couple days later, same bug ticket, click, 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 cannot reproduce, closed. Who wants to go to lunch? A couple days later, the exact same bug, click, 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 cannot reproduce, snarky little comment about the anatomy of a good bug report, closed. And I tried. I couldn't reproduce. I tried. I really tried to reproduce it. And it turned out it was disproportionately affecting one customer. And so what we did is we actually, they were in the middle of a very high-profile case, and in that process, they ground to a halt. They were running discovery 24/7. They were running discovery around the clock in different parts of the world. And at one point in the middle of the night, everything just shut down. And so they called the attorney of record. We were doing e-discovery. They called the attorney of record on the project, who called the account manager, couldn't get a hold of anybody. Finally, somehow, through hours of Googling, managed to find the cell phone number of the president of the company. Called the president of the company up in the middle of the night, and he sent an email out and said, he sent an email out to the rest of the team saying, emergency all hands developer meeting, 7:30 a.m. Now, he emailed that out about 11:57 p.m. And if you were to make a Venn diagram of developers who are naturally in the office at 7:30 and people who read work email in the middle of the night, I'd be over there. I'm not a morning person. I don't like the traffic. I think that the traffic tends to die down around 10 o'clock, and so that's when I wake up. If I'm going to be really late, I would always bring snacks. I'd buy donuts or something. So that would just take the edge off of me being late. They'd be like, dang it, Mike, you're late again. But you brought donuts. You're okay by me. And that's what I did. So that particular day, I rolled in around 10:30-ish. Literally walked into this. It was going down. It wasn't pizza, it was donuts, but that's pretty much what happened. Everything was on fire. My colleague saw me, looked over, he says, George was looking for you. And I said, oh, how long ago? He says, oh, about 3 hours ago. And I saw George. We ended up having to try to debug the entire thing in production with production data. And it was a really difficult thing to do. We had to build an entire test land. But as we started going through it, I saw something. As we're stepping through the code, repair programming this, I hear a sound coming out of myself. It's a sound that a developer makes when they see something impossible. I know this because I do a lot of magic for software engineers. The best you get in terms of reactions from software developers when you show them something truly magical is, huh. Regular people will scream, they'll run away, they'll make a big exaggerated reaction. Developers go, huh. And as I'm step, huh, I see something. My colleague starts getting a little worried. And I said, we haven't found the problem yet. He says, oh, no, that's the problem. And I said, that can't be the problem. The only way that could be the problem is if we were getting hash collisions. And he starts muttering something. I'm like, don't be ridiculous. We're not getting hash collisions. And I'll prove it to you. Look, FEA6, huh? Step, huh. We're getting hash collisions. This is a big deal. We're going to be famous. What did we break? Did we break SHA-256? SHA-512? We broke SHA-512? SHA-1? MD5? CRC? Come on, throw me a bone here. Turns out the dude rolled his own hashing algorithm. Just because he said it was faster. It wasn't until a couple days later he comes in the office. He took a day off after that. He's pretty upset. Comes in the third day. I said, hey, team room in 5? And he goes in there, and I finish up what I'm doing, and I join him. I sit on the edge of the table, and I said, Corey, what the hell were you thinking, man? And just then, it all kind of echoed back to me. And he was actually very articulate. This annoyed me. He was very, very articulate. But, and he said it was faster, and I was dying to know. I said, how much faster? Turns out it would shave 5 milliseconds off a 490 millisecond API post. And because I'm that kind of person, I did the math. And yes, we would reach the heat death of the universe before that was a worthwhile optimization. So obviously, there were some problem-solving anti-patterns here. But I understand why we do this. I understand why we do this because we work at higher and higher levels of complexity. If we've been around in this industry for long enough, we start letting go of things that matter. We fall victim to something called imposter syndrome, where we start thinking that we're not really as smart as we really are. We look at everybody else and we think they're smart. And we feel guilty. We get a complex about this. So it's important to kind of be aware and self-aware and understand that imposter syndrome is a thing. And we can keep talking about what the definitions of great programmers are. And in my pursuit of greatness, I ended up falling prey to all of the different problem-solving anti-patterns. So where do we go from here? And the answer is to be incrementally improving. Not to look for big improvement, but incremental improvements. Empathy is one of the most important skills that we as software engineers can cultivate in our careers. I firmly believe, more important than anything else, empathy. And come to my talk on value-driven development if you want to dive a little deeper into that and why it's actually very relevant. Being able to think slowly and carefully, studying other solutions. Now, obviously, that requires humility Be curious, broaden your knowledge. Like literally everything that we learn in our career builds a platform for everything else that we're going to learn. So these are really valuable things. I did a podcast last year with Dr. Venkat Subramaniam, and if you want to find that, check that out. Lifelong learning, and I'll retweet that today, but listen to that. There's a lot of value in there. Empathy is really important, but just to bring everything home, the key and the secret is to approach everything from a value perspective. Because great programmers consistently bring value to the team and to the organization. And being able to create value is a skill that will last longer than any language, any framework, anything you learn. And ultimately, if you're solving the problem of the business and solving the problem of the customer, then you are creating value. And the key thing is when you understand value, you're able to deliver it. And this is why I'm a proponent of Agile, because value and understanding drive effort. And if you understand why you're doing what you do and the value of what you create, instead of incrementally delivering functionality, you can incrementally deliver value and create a better experience for everybody else. So to bring this all home, what are the opposite of the problem-solving hallmarks? Are the problem-solving anti-patterns or the problem-solving hallmarks? Leverage existing resources to increase your output. Pick your battles. Not everything is life and death. Focus on work that delivers the most business value over the most interesting work. Deliver just enough, just in time. Recognize good enough. Collaborate. Act as a thought leader in your organization. Use the right tool for the job, and look at problems from the perspective of the business and from the customer, because ultimately that's where our paycheck comes from. And some of these take years to really get good at, but they're things that are important to keep in mind. And I know we're out of time, so with that, I will say thank you for your time and attention and being here today at GIDS Data and Cloud. Thank you so much. Thank you.